Hello everyone, so welcome to our General Chemistry 1 class. So in chemistry, any computations, especially in stoichiometry, we have to start with the balancing chemical equations. So before you compute, for example, for a limiting reagent, you have to make sure that the chemical equation that you have or that you are solving is already balanced. So we have here 3 steps for you to balance the chemical equation. So let's just have a recap. So first step is you have to identify the elements on each side of the equation. So for example, we have here the unbalanced chemical equation. So sulfur on this side has 8 atoms, on the other side it has 1. So this is clearly unbalanced. So just enumerate all the elements mentioned in the reactant side and also the elements mentioned or in the product side. After which, you just count the atoms on each side of the equation. So for example, sulfur has 8 atoms on the reactant side, oxygen has 2. In the product side, sulfur has 1, oxygen has 2. So for step 3, we have to manipulate the coefficients in the reactant side and also in the product side by finding the right value to be multiplied in the subscripts of elements involved in the chemical equation. So since sulfur here has 8, on the other side it has 1, let's multiply it. Let's try to manipulate it by multiplying by 8. So where are we going to put 8 in the product side? In the coefficient, because we are not allowed to touch the subscript side. So just put in the coefficient 8. So 1 times 8, therefore sulfur now has 8 atoms. And for oxygen, since 8 coefficient here will affect as well the whole of the product. So oxygen now has 16. So 2 times 8. On the other side, in the reactant side, you can see that the oxygen has 2 atoms. So let's manipulate this as well. So we are going to multiply oxygen with 8. So by placing that 8 in the coefficient of oxygen in the reactant side. So this time oxygen has 16 atoms balanced with the oxygen in the product side. So this equation now is balanced. So this is now the balanced chemical equation. So as a sort of check, sulfur has 8 atoms in the reactant side. In the product side, sulfur has also 8 atoms. Oxygen has 16 atoms in the reactant side. Oxygen here is also has 16 atoms in the product side. So let's recall stoichiometry calculations. So it's mentioned that this equation is already balanced. So if we have 5.5 moles of Fa2O3, how many number of moles of SO3 is needed? How many grams of SO3 can react with it? So let's start with computing this Fe sub 2 O sub 3. So how many number of moles of SO3 is needed. So let's compute for this first question by doing this formula. So this one is given, it's in here. And this one, 1 mole Fa2, it's the coefficient. We are using the coefficients in the given chemical equation. The 3 mole SO3 is here. So using your calculator, 5.5 times 3 divide by 1, you will get 16.5. Just cancel out this one. You will have your final answer is 16.5 mole SO3. So that is the answer for the first question. For the second question, this one, mole SO sub 3, just convert this one to grams. So where can we find these numbers here? So just locate these numbers in the periodic table, the atomic mass unit of sulfur is 32 grams per mole. Then oxygen in the periodic table is 15.9 something. You can round it off to 16. Then times 3 because of its subscript na 3. So just use your calculator. 32 plus 3 times 16. Multiply to here and you'll arrive at this answer. So this is the answer for the second question. Now let's go to the topic that we are talking about, the limiting reagent. So there are 3 methods in finding the limiting reagent. So as a sort of recap, limiting reagent is also known as limiting reactant. So this is the reagent that is completely used up or reacted. So the first one that can be used up. Then for the excess reagent, this is also known as the excess reactant. This is the reagent that is not used up when the reaction is finished. So let's have an example. So find the limiting reagent in the given balance equation. So if we said that it's balanced, so we do not have to go over in balancing this equation because it's balanced already. So we are given the mass of aluminum in grams, of course, and grams of chlorine as well. So we have to convert these amounts from grams to moles. So from 2.80 grams aluminum, convert this one to moles. So let's just use this conversion factor. So where can we find this 26.98? It's in the periodic table. So 2.80 times 1 divided by 26.98 will have this answer, or 0.104 moles aluminum. For chlorine, we have here, let's convert this 4.25 grams chlorine to moles. So again, using your periodic table, the atomic mass unit of the chlorine, just multiply it to 2 because of the subscript 2. You'll have the answer, which is 0.0599 moles chlorine, or 5.99 times 10 to the power of negative 2 moles chlorine. Okay, so let's try to use the 3 methods of finding the limiting reagent. The first method is, okay, so we have already the moles of aluminum and the number of moles of chlorine. So let's just use the actual ratio and the stoichiometric ratio. So we are going to compare them. So if the consequent, or the consequent is the element in the denominator, then the element in the numerator is the antecedent. So if the situation is, if the actual ratio is greater than that of the stoichiometric ratio, then the element in the consequence, so the element in the denominator is the limiting reagent, and the element in the numerator is the excess reagent. So using the actual ratio is the one that is given. The one that is given, the one that we convert to from grams to moles. So it's 1.04 times 10 to the power of negative 1 divided by 5.99. So the answer is 1.74 moles Al. Then of course the denominator is Cl2. For the stoichiometric ratio, we are going to use the equation. Okay. Recall that 2 moles Al, 3 moles Cl2. So we are going to use that one. 2 divided by 3, it's 0.67. Of course, Cl2 ang nasa denominator. So comparing the two, the actual ratio is greater than that of the stoichiometric ratio. Therefore, the element in the denominator is the limiting reagent, and the one in the numerator is the excess reagent. Consequent means the element in the denominator. Okay, using the method 2, so we are going to analyze it. No? We're going to analyze it. So just randomly pick, but for me, we are going to try to explain it like this. So the given for moles of aluminum is like this, 1.04. So let's try to use everything, all of these amount of moles in the given. So let's try to use this up. And as you can see, the answer is less than the actual number of moles of Cl2. So therefore, this is the limiting reagent. Anyway, my computations pa rin ito. We can also try to solve the number of moles of this Cl2. Okay, let's try to use up the 5.99 times 10 to the power of negative 2 in the reaction. So the outcome is invalid kasi more than the given ang lalabas. So it's invalid. So the equation that is useful is this one. Okay, if we completely use up the number of moles of aluminum, we can see that this number of chlorine is less than the actual number of the given. That means this one is the limiting reagent. Again for clarification, so in method 2, I am solving this problem like this. Like if you're going to use up all the given moles of aluminum, it will come out like this, which is 1.56 times 10 to the power of negative 1 mole Cl2, and compare it to the given. So this is not anymore available kasi the given is less than this. So this equation should be the one that is invalid. On the other hand, if we're going to use up this one, 5.99 times 10 to the power of negative 2 moles Cl2 times 2 moles Al, then divide by, so let's do the reverse na this time for their ratio. What will come out is that the number of chlorine that will come out is not chlorine, aluminum, because we're trying to use up the chlorine. The number of alumins that will come out is 0.04, which is less than in the given. So this is the one that we are going to the equation that is not shown here is the one that we are going to consider. And of course, the aluminum is in excess, so it's the excess reagent, and the chlorine is the limiting reagent. Anyway, I'm going to explain further this method in the other video. And for method 3, they are making use of this equation. 1 mole reaction equals 2 moles aluminum equals 3 moles chlorine. Of course, this equation here comes from the given chemical equation. But may nakikita kung parang mali itong 2 moles chlorine kasi sabi dito 3 moles chlorine dapat. So ito lang yung typographical error. So we are going to compare these two here, and it says use this relationship to set up ratios to convert the moles of each reactant to moles of reaction. The reactant with fewer moles of reaction is the limiting reagent. So among the two, ito yung fewer. So therefore, the chlorine reactant is our limiting reagent. So I am not familiar of these two methods, the method 2 and 3, but I can show you the method 2 in the other video. I can show you the illustrations. And of course, in computing for this percent yield, wherein we're going to take note of the actual yield in grams and theoretical yield in grams, we are going to focus on the limiting reagent, of course. So that ends our video. Thanks for watching and don't forget to subscribe.